Hello everyone! In this video, I will show you how to write object-oriented code in Lua. Lua isn't an object-oriented language, but it is possible to emulate the behavior of classes by using tables, and I will show you how to do that. Before beginning, please don't forget to like, comment, and subscribe to support the channel. Let's begin! You may be wondering why object-oriented programming? Well, it is widely used in game development because games include several different components, behaviors, and values, and object-oriented programming is a programming style that is used to organize code in a way that is non-repetitive, easier to understand, modify, and maintain. OOP organizes code into objects. Objects contain information about state and behavior. States are the characteristics of objects, such as on and off. Behaviors are the things an object can do, such as shooting. To explain how to write object-oriented code in Lua, I should first tell you about tables, because we'll use tables as objects to achieve object-oriented programming. Tables are the only data structure in Lua, and they are very powerful. Tables can store multiple types of values, including numbers, booleans, strings, functions, and more. Say we have a table named table1 that includes A and B as elements. These A and B can be simple data, such as numbers, string values, or they can be functions or other tables. We can add or remove elements, and we can change the existing elements in a table. I have an empty project here. I have created a script under server script service. Here, I'll create a table. Local table1 is equal to curly brackets to construct the table. I'll create the table with two elements. A is true and B is 5. This is a very simple table. Let's print some elements. Print table1.b, let's say. If I run this, we can see the value 5 here. If I try to print another element like C, which is not defined in the table, if I run it, it will return nil. These are very basic behaviors of the table data structure in Lua. But tables are more powerful than they seem, and we have some control over the behavior of tables in Lua. This is where it gets interesting. To define a behavior for a table, we again use a table, because it is the only data structure we have in Lua. A table that defines the behavior of another table is called a metatable. So for table 1, we would have metatable 1. Any table can have a metatable. Metatables have predefined fields that we can modify to achieve custom behaviors. Some examples are __index, new index, call, and so on. There are more of these. The ones that I show you here are the most commonly used ones. These are called metamethods. These names are predefined, and we can change their values in order to change the behavior of a table. So we have a table 1 here, and another table called metatable 1 with various predefined metamethod names in it. How are we going to make the connection between these two? It is quite easy. We have a method called setMetatable. It has two parameters. The first one is the table itself, and the second one is the metatable that we are going to assign for the first parameter. So with this expression here, we are assigning metatable 1 as a metatable for table 1. For object-oriented programming, the most important metamethod is __index. This is an important metamethod because when an element is not found in a table, this __index method is used to search for the element in the metatable. For example, we have a table 1 with elements A and B. But similar to the example we had, let's say we are looking for a variable called C and we want to print its value. C is not defined in table 1. So in Lua, it is first checked if C is in table 1 or not. If it is there, C's value will be returned. But if C is not in table 1, the code checks if there is a metatable defined for table 1. In the example we did in Roblox Studio, we didn't define any metatable. So it returned nil when we tried to print an element that wasn't defined in the table. But if there's a metatable defined for table 1, in this case, it will check if __index is set to a value. So this __index can have two different types of values. It may be a function or it may be a table itself. If it is a function, it will run that function and return the return value of the function as the value of C. If it is a table, Lua will try to find C in that table. I hope you are still with me. Let me show you an example. Here, I'll create a table named metatable1, like we have talked about. Now, I'll go setMetatable, table1, metatable1. By doing this, we have set metatable1 as the metatable for table 1. Also, as we have discussed, I'll type metatable1.__index is equal to, first let's try using a function. So function print no such entry. I'll cut this from here and paste it here. Before, when I told it to print table1.c, it returned nil. Now, if I run it, it first returns no such entry, then it returns nil. First, it looked in table 1, it couldn't find C there. Then it checked if there's a meta table set for the table, and yes, it was set here. Then it looked for the __ index element of meta table 1. There's a function defined for that, and it ran that function. There is no return statement in the function, so the function returned nil. Hence, the print statement here also returned nil. Here, if I type return 0 and run, it will return 0 after saying no such entry. So we can define what it will return by creating a function here. As I mentioned, __ index is a meta method, and meta methods invoke when something happens to the table its meta table is connected with. So when we index a table with a value that doesn't exist in it, such as table1.c, when there isn't any c in table 1, then the __ index meta method fires. Also, as we have discussed, we can use a table for __ index. Let's create another table called extended table. We may put in some elements in it, like c is equal to 3.5 and d is equal to an empty table. Let's comment out the function. Instead, I'll set __ index to the extended table. So if we set a table for the __ index element of the meta table, like we did here, if an element cannot be found in the original table, the code will check if it is inside the extended table. In this case, it should return 3.5 because it is in the extended table. Let's run. 3.5 as we expected. But if I try to print E, it will not be found in the original table or the meta table, so it will return nil. Since meta table is a table itself, most of the time we don't use another additional table like this extended table here for it. Instead, we put the elements directly in the meta table. And while setting the __ index, we'll use meta table 1. So what we are doing here is to tell Lua if it cannot find a value in table 1, it should look in the meta table 1 itself and see if that element is defined somewhere in the meta table. If I type C here and run, it returns 3.5. So we don't need to create an additional table to use a table as the __ index. We may also have some functions inside the meta table as well, which is maybe the most important part of the object-oriented programming implementation. Here, if I go say hello is equal to a function, and inside, if I type print hello, if I come here and go table1.say hello and run, it will return hello, although it is not defined in the original table, which is table 1. So we'll basically be using this concept in order to emulate object-oriented programming in Lua. In object-oriented programming, we have classes. Classes are template definitions of the methods and variables in a particular kind of object. In Lua, classes correspond to metatables. We usually create an instance of a class using that class itself. We can have a similar functionality in Lua as well. To do that, we'll create a function inside the meta table. It is usually called new, as used in various other languages. The new function creates a new table for the instance and, if required, does some necessary adjustments such as setting properties. It sets the meta table for the new table, which will be the meta table itself, and returns the new table as the return value. Let's create this functionality here. Usually we go metatable1.new. As I mentioned, using new is a common way of creating an instance of a class. That's why we use new here. It will be a function. It may have some parameters. Let's call them _a and _b. And what it does is, as we have discussed, it will first create a new table. Let's call it new table. If required, it may make some adjustments, like there are some parameters here. We can set some properties with these parameters. So new table.a, for example, is equal to _a, and new table.b is equal to _b. Then we are going to set the new table's meta table. Set meta table, new table, and it is going to be the meta table 1 itself. And finally, it will return the new table. So this is a general way of creating metatable.new function. How are we going to use that? For example, local table 2 this time, it will be metatable1.new, and I'll use 1 and 2 for the a and b arguments. If I print table 2 right now, when I run, we'll see that the table has a variable called a, which is equal to 1, and b, which is equal to 2. Another important thing to notice is that it is created by using the meta table. So we can also call table2.sayHello and it will say hello, similar to table1 here. So it is like creating an instance of a class by creating a table from a meta table. Let's comment these out. Usually the structure is like this. Local class is a table which is going to be meta table. We define the new method here, which will be a function. It usually takes in itself and a table if you already created. Here we are creating a local new table and it is going to be equal to underscore table. But if it is not set to something, we'll create a new table. If you are not familiar with these logical operators and could use a guide, I suggest you watch the logical operators video. The link is on the card and in the description. Okay, it will set that new table's meta table as self. Also, we'll go self.__index is equal to self, which means if you cannot find something in the new table, you should look in the class table itself. Finally, it will return new table. This is the most common way of writing a meta table structure. And in order to create an instance of it, we can use class colon new. We don't have to specify a table, but if we want to, we can pass in a table as well. And this colon syntax is the same as local instance is equal to class.new class. If you use a dot, you should also supply the self here, which is the class itself. But if you use a colon, you don't have to specify the class. It will be passed in automatically since we are using a colon. So this is a very common structure of a class and instance implementation in Lua. Let's have an example here. Let's have a class called gun. It is going to be a meta table, so equals to table. And gun.__index is equal to gun, which means if you search for an element in a table and if you cannot find it, and if the gun table is the meta table of that table, you should look inside the gun table that is the meta table. We can also have some variables like gun.damage is equal to 1, gun.cooldown is equal to 10. These are some default values that we may use in our implementation so that each instance of the class would come with these default values. Also, we may have some methods or functions that define behaviors. They are the most powerful part of object-oriented programming really. Gun.shoot is a function and it will print shooting. And maybe another one, gun.reload is going to be equal to function print reloading. So these are some example implementations of these functions to keep it simple here, but in real games we'll have more complex implementations of shooting and reloading of course. As we have discussed, we have gun.new equals to function. It will take in the self information and also we may use some parameters here like _damage and _cooldown. And here, as we have discussed, it will create a new table. We are gonna set damage and cooldown to these parameters if they are not nil. So if _damage, then new table.damage is equal to _damage. And also, if we have a cooldown value here, then new table.cooldown will be equal to _cooldown. These are some adjustments we do for the new table. Now we are gonna set meta table for the new table. So new table and self. And we'll return the new table. So this is our class-like meta table. How are we gonna use that? Let's create a small gun instance. Local small gun is equal to gun colon new. So if we print the small gun right now, it will show a table here for us. Although the table doesn't show damage and cooldown values, we can ask for these because we know they are there. I'll copy this and type .damage and .cooldown. If I run, we can see 1 and 10 as the default values here. We can use some of the methods here as well. I can call shoot. If I run, it will read shooting. It's called the shoot method here. So this was without having any arguments. Let's have one with a few arguments, like 10 for the damage and 2 seconds for the cooldown. Let's get rid of these. If I press play, you can see that cooldown is 2 and damage is 10. It prints shooting as well. Similarly, we may have another gun, which will be big gun. Let's replace these with big gun. This time, it will have 30 damage, but it will take 3 seconds to cool down. We can shoot it. Also, we can use .reload since these methods are defined in the meta table. When I press play, the first one is 2:10, the second one is 3:30, and shooting and reloading for the big gun. As you can see, we haven't defined these shooting or reloading methods for the small gun or the big gun. But since we use the meta table to create these instances, they automatically have the shoot and reload methods. Object-oriented programming paradigm is really useful for game development since we usually want different instances of a template with some variations in our games, such as different weapons, NPCs, or obstacles. Similarly, we can implement inheritance as well. Inheritance is a mechanism where we can derive a class from another class and inherit the attributes and methods of the parent class. Here we have instances of gun, but gun can be inherited from weapon, for example. That would be an upper level class. So let's create another meta table here. Local weapon is a table, and very similar to what we did before, weapon.__index is equal to weapon. And like the gun, we may have some properties and methods. Let's go weapon.weight is equal to 100. This will be the default weight for the weapon. And we may have some methods like weapon.drop is going to be a function. And very similarly, I'll go print dropping. And we'll have a new method for that. It will be a function like we did before. It will take in self and we'll have the weight information here. First, we'll create a new table. Local new table is equal to a table. If _weight is not nil, then we can set the new table.weight to _weight. Set the meta table of the new table as self and return new table. So here we have created a weapon meta table. And the gun meta table will inherit from the weapon. Instead of creating an empty table here, we are gonna use weapon colon new so that it will be created from this new method here. So the guns meta table will be the weapon. In order to be able to adjust the weight of that, here I'll add another parameter, _weight. And instead of using this line, I'll go local new table is equal to weapon colon new _weight. So if we create a gun here by calling gun.new, it will create an instance of the gun, which is an instance of the weapon. So if the code cannot find a value inside the table, it will look for it in the gun table. And if it cannot find it there as well, it will look for the value in the weapon table. Let's do the adjustments here. For example, the weight will be 200 for the small gun and 400 for the big gun. If I press run, it works. If I add small gun.drop here and also big gun.drop here and run, it will be able to find these methods for the small and the big guns because it will first check the table itself, then the meta table of the table, which is gun, and the meta table of the gun, which is weapon. And the drop method is right here in the weapon meta table. One last thing I'd like to mention is that we can overwrite the methods that are defined. For example, here we have drop. We can overwrite it in the child class that inherits from a parent class. The child class is gun in our case. If I type here gun.drop is equal to function print special drop, and as you can see when we ran it before, dropping was printed here and here. If I press play, it now says special drop in both places. So we can overwrite the values of methods inside the children class meta tables. To sum up, basically, if we are asking for a method or an element of an instance, first it will look for it in itself, then in the meta table of it, then in the meta table of the meta table, and it goes up like this. If it finds that method or value, it will return that. If it cannot find, it will do the upper level search. If it cannot find it in any level, it will return nil. But if along the way it can find it, it will return the found value. So this is how you can implement object-oriented programming in Roblox Studio using Lua. I hope you enjoyed the video and it helps you. Please like and subscribe to support the channel for more videos. If you want a new game development tutorial, let me know in the comments. You can get access to the Roblox project file from Patreon. The link is in the description. Thanks for watching and I'll see you in the next video.